Welcome to Sleepy Science Hub. Tonight, we're going to explore one of the most profound transformations our planet could experience. What would happen if we suddenly lost our constant companion, the moon? As you settle in, let me know where in the world and at what time you're watching. Perhaps you're looking out your window at the moon itself right now, or maybe you're nestled under covers while clouds drift peacefully across the night sky. Wherever you are, whatever time it is, imagine a world where that familiar silver orb no longer graces our evenings, and consider how gently, gradually, everything would change. Now, get comfortable. Take a slow breath, let your shoulders drop, and let's begin this peaceful journey through a transformed Earth. Picture yourself stepping outside on what would have been a full moon night, but instead of the familiar bright silver disk that has watched over humanity for millennia, you find yourself beneath a sky deeper and darker than you've ever experienced. The absence is profound, but not frightening. Rather, it's like discovering a completely new dimension to the night, as if someone has drawn back heavy curtains to reveal stars that were always there, but somehow hidden by the moon's gentle radiance. Without the moon's bright presence washing out the fainter lights of the cosmos, the night sky becomes a vast cathedral of starlight. The Milky Way, that ghostly river of distant suns that modern city dwellers rarely glimpse, now stretches across the heavens in all its magnificent glory, a broad band of soft luminescence that seems to pulse gently with the light of billions of distant worlds. Stars that were previously invisible to the naked eye now twinkle softly in the darkness, creating constellations within constellations, patterns within patterns that transform the familiar dome of night into something entirely new and wondrous. The darkness itself feels different, not the harsh, empty black that you might fear, but rather a soft, enveloping darkness that seems almost alive with possibility. Your eyes, no longer competing with the moon's brightness, begin to adapt to this new level of darkness with remarkable sensitivity. Within minutes of stepping outside, you find that you can see far more than you initially thought possible. The subtle differences in the darkness become apparent. The way starlight reflects off a distant lake, the gentle silhouette of trees against the star-filled sky, the soft glow of the aurora that becomes visible much farther south than ever before, no longer outshone by lunar light. Cities around the world experience their own transformation in this moonless night. The artificial lights that have always competed with the moon's glow now seem somehow gentler, more harmonious with the natural darkness. Street lamps create pools of warm yellow light that fade softly into the star-filled darkness beyond. Building lights twinkle like earthbound stars, creating their own constellations that mirror the celestial display above. The harsh light pollution that once masked the glory of the night sky seems somehow softer now, as if the absence of the moon has taught humanity to light their world more gently. In rural areas, far from the glow of cities, the transformation is even more profound. Farmers stepping out to check on their animals find themselves in a world that seems borrowed from a fairy tale. The familiar barnyard, the well-known path to the fields, the comfortable shapes of trees and fences, all of these take on new mystery and beauty in the deeper darkness. But this is not a threatening mystery. It's the gentle mystery of discovering that the world you thought you knew completely still holds surprises, still has new faces to show you. The wildlife of the world begins to adapt to these darker nights with remarkable speed and grace. Nocturnal creatures that have evolved to hunt and navigate by moonlight find that their other senses become more acute to compensate for the reduced visibility. Owls, those silent hunters of the night, discover that their extraordinary hearing becomes even more crucial to their success. Their calls echo through the darkness with a new clarity, as if the absence of the moon has somehow purified the acoustic environment, removing some subtle background interference that no one ever noticed before. Night-blooming flowers, those delicate beauties that have always opened their petals to catch the moon's gentle rays, adapt their schedules to the new rhythm of darkness and starlight. Some species find that they bloom more frequently in the deeper darkness, as if they were always meant for a world lit only by stars. Others adjust their flowering times to coincide with the brightest star clusters or the subtle seasonal changes in the position of the Milky Way. Gardens around the world begin to show new patterns of beauty as these night bloomers explore their new relationship with the cosmos. Photographers and astronomers find themselves in paradise. Without the moon's interference, deep sky photography becomes possible with equipment that would have been inadequate before. The delicate spiral arms of distant galaxies, the colorful nebulae where new stars are born, the subtle details of planets and star clusters. All of these become accessible to amateur observers with modest telescopes. Observatory schedules around the world are rewritten as every night becomes potentially perfect for astronomical observation. No longer subject to the lunar cycle that previously dictated when the best viewing conditions would occur. The rhythm of human sleep begins to change in subtle ways. For thousands of years, human circadian rhythms have been influenced not just by the sun, but by the moon's phases. In this new moonless world, people find that their sleep patterns gradually shift towards something more closely tied to the seasonal changes in starlight and the position of celestial objects. Some individuals discover that they sleep more deeply in the profound darkness, while others find that the magnificent star displays visible from their bedroom windows inspire them to spend more time in quiet contemplation before sleep. Tidal pools around the world, those delicate ecosystems that exist in the space between high and low tide, begin to experience a gentler rhythm. Without the moon's gravitational pull to create the dramatic tidal ranges that have shaped these environments for millions of years, the water levels change more gradually, more gently. The creatures that live in these marginal spaces, the sea anemones, the hermit crabs, the delicate algae that paint the rocks in subtle colors, find that their world has become less chaotic, less subject to the dramatic changes that once swept through their environment twice each day. Children around the world discover a new kind of magic in the night sky. Without the familiar moon to serve as their first astronomical teacher, they learn to navigate by the stars themselves, developing an intimate relationship with the constellations that previous generations lost as artificial lighting spread across the planet. Parents find themselves rediscovering the names and stories of the star patterns as they share these moonless nights with their families, creating new traditions around stargazing and the gentle science of reading the heavens. The seasons take on new significance as the primary markers of change in the night sky. The way the Milky Way rotates through its annual cycle becomes more prominent in human consciousness. The subtle changes in which stars are visible at different times of year become as familiar as the changing colors of leaves or the migration patterns of birds. People begin to mark important events not by the phases of the moon, but by the position of bright stars and constellations, creating new calendars based on stellar rather than lunar cycles. Artists and poets find new inspiration in the transformed night sky. The deep darkness punctuated by brilliant starlight creates a different aesthetic than the familiar interplay of moonlight and shadow. Painters discover new ways to capture the subtle gradations of darkness, the way starlight catches on water or frost, the gentle glow of the aurora now visible much farther from the poles. Writers find themselves reaching for new metaphors to describe the beauty of this star-filled darkness, this gentle night that enfolds the world in its cosmic embrace. The science of meteorology begins to adapt to the new conditions as well. Weather patterns that were once influenced by the moon's gravitational effects, subtle but measurable changes in atmosphere pressure and wind patterns, slowly shift to new configurations. Meteorologists discover that their predictions become slightly more accurate in some ways, as one variable in the complex equation of weather forecasting has been removed. The atmosphere itself seems to settle into new patterns, like a symphony finding a new key in which to play its eternal variations. Navigation, both for humans and for the migrating animals that cross vast distances twice each year, begins to rely more heavily on stellar positioning. Sailors rediscover the ancient arts of celestial navigation, finding that the brilliant star displays, now visible every clear night, make it easier to determine their position with accuracy that rivals modern electronic systems. Birds and other migrating animals show remarkable adaptability, shifting their navigation strategies to rely more on magnetic fields and star patterns rather than the lunar cues that have guided their journeys for countless generations. The fishing industry adapts to new patterns as well. Fish populations that once moved according to tidal rhythms influenced by the moon now establish new migration and feeding patterns based on the subtler gravitational influences of the sun and the seasonal changes in water temperature and current flows. Fishermen around the world find that they need to learn new timing for their expeditions, developing expertise in reading the signs that fish populations give when they're not following lunar influence schedules. Surfing and other water sports experience their own transformation. Without the dramatic tidal changes caused by lunar gravity, wave patterns become more consistent, more predictable. Surfers find that their favorite breaks behave differently, sometimes better, and sometimes requiring new techniques. The rhythm of the ocean becomes more closely tied to wind patterns and seasonal changes rather than the twice-daily pulse of lunar tides. Coastal communities develop new relationships with their shorelines as these areas become more stable, less subject to the dramatic changes that once carved and recarved the boundary between land and sea. The absence of moonlight creates new opportunities for bioluminescence to shine. In tropical oceans, the microscopic organisms that create those magical displays of living light in the water become more visible and more prominent in the ecosystem. Night swimming in these waters becomes an even more enchanting experience as the gentle movement of swimmers through the water creates streams and spirals of blue-green light that were previously often washed out by moonlight. These bioluminescent displays become more important to the creatures that create them, serving as communication and mating signals that can now be seen more clearly across greater distances. The transformation extends to the most intimate aspects of human experience as well. The gentle darkness of a moonless world changes the way candlelight looks in a window, the way campfires appear against the star-filled sky, the quality of light that filters through curtains from the street lamps outside. These subtle changes in the visual environment create new moods, new feelings, new ways of experiencing the familiar spaces of home and community. The night becomes more truly night, more deeply restful, more profoundly peaceful in its embrace of darkness punctuated by the eternal light of distant stars. Along the coastlines of the world, where the endless dance between land and sea has played out the same rhythm for millions of years, something profound and gentle begins to change. Without the moon's gravitational embrace pulling at Earth's waters, the familiar pulse of the tides, that twice-daily breathing of the ocean that has shaped every shoreline, every estuary, every tidal pool, begins to soften into something entirely new. This transformation doesn't happen with violence or sudden disruption, but rather like a great symphony slowly changing key, finding new harmonies in the eternal relationship between water and shore. The morning walker along a familiar beach notices it first as a subtle difference in timing. The high tide that usually reaches the weathered piece of driftwood that has served as a landmark for years now falls just short, leaving a few more feet of sand exposed. The water still rises and falls, but with a gentler amplitude, following the sun's gravitational influence alone. Where once the tide might have risen 8 feet above low water, it now climbs only 3 or 4 feet, creating a kinder, more predictable interface between the terrestrial and marine worlds. This gentler tidal range reveals parts of the shoreline that have been hidden for millennia. Rocky ledges that were exposed only during the most extreme low tides now remain visible for hours each day, providing new habitat for pioneering species of algae and barnacles. Tide pools that once experienced dramatic changes in water level every 6 hours now maintain more stable conditions, allowing their delicate ecosystems to develop greater complexity and diversity. The hermit crabs scuttling among the sea anemones find their world has become more predictable, less subject to the harsh changes that once swept through their environment twice daily. Estuaries around the world those crucial nursery areas where rivers meet the sea, experience a profound transformation in their character. The mixing of fresh and salt water that once varied dramatically with each tide now achieves a more stable balance. The salt wedge that pushes upstream with each high tide no longer penetrates as far inland, allowing freshwater fish species to expand their range toward the coast. Young salmon preparing for their journey to the ocean find that the transition between fresh and salt water has become more gradual, less shocking to their developing systems. Harbor towns and coastal cities begin to adapt to the new rhythm of their relationship with the sea. Fishing boats that once planned their departures around high tide schedules now find they can enter and leave port more flexibly, though they must adjust to shallower water levels overall. Ancient harbors that were dredged to accommodate the deepest low tides now require careful navigation. But the more predictable water levels make scheduling and planning simpler for maritime commerce. The great river deltas of the world experience their own gentle transformation. The Mississippi Delta, the Nile Delta, the vast Ganges Delta, all of these landscape features begin to stabilize in new configurations as the reduced tidal action allows sediment to settle more consistently. The twice-daily scouring action of strong tides that once redistributed massive amounts of sand and silt gives way to gentler processes driven primarily by river flow and seasonal changes. These deltas begin to build outward more steadily, creating new land at a different pace than before. Coastal wetlands, those incredibly productive ecosystems that serve as nurseries for countless species, adapt to the new tidal regime with remarkable resilience. Salt marshes find that their upper reaches, once flooded only during the highest tides, now remain dry and begin to transition toward terrestrial plant communities. The lower areas develop more stable salinity levels, allowing for the evolution of specialized plant communities that weren't possible under the old regime of dramatic tidal fluctuations. Mangrove forests, those remarkable ecosystems that thrive in the challenging environment where land meets sea, begin to expand their range as the reduced tidal action creates more stable growing conditions. The intricate prop root systems that have evolved to withstand dramatic changes in water level now support even more diverse communities of fish, crabs, and other marine life. The calmer water between the mangrove roots becomes clearer, allowing more sunlight to penetrate and supporting expanded populations of sea grasses and other aquatic plants. Shipping and navigation industries around the world gradually adapt to the new conditions. Ports that once relied on high tides to allow large ships access to their harbors now require different approaches. Some ports find they must dredge deeper channels to accommodate vessels that previously could ride the high tide to reach their berths. Others discover that the more predictable water levels actually make navigation easier and safer, removing the time pressure that once forced ships to arrive and depart within narrow tidal windows. The surfing community experiences a profound shift in their relationship with the ocean. Surf breaks that once varied dramatically with the tide now produce more consistent waves, though sometimes smaller ones. Surfers find they need to learn new techniques and timing for breaks that once followed predictable tidal cycles. Some legendary surf spots that depended on extreme low or high tides to produce their famous waves become less spectacular, while others that were previously average discover new excellence in the changed conditions. Marine life throughout the world's oceans begins a gradual adaptation to the new tidal regime. Fish species that once timed their spawning to coincide with specific tidal conditions develop new reproductive strategies. The great migrations of fish, crabs, and other marine creatures that once followed lunar and tidal cycles begin to sync with different environmental cues, seasonal temperature changes, daylight patterns, and the availability of food sources. Coral reefs, those underwater gardens that support an enormous diversity of marine life, experience their own transformation. Many coral species that evolved to take advantage of tidal flows for feeding and reproduction adapt to the gentler water movements. The reduced water exchange between reef and open ocean creates more stable local conditions, sometimes leading to warmer water temperatures that encourage different species compositions. Some reefs become more dominated by hard corals, while others shift towards soft coral and sea fan communities. The commercial fishing industry adjusts to new patterns as fish populations redistribute themselves according to the changed ocean conditions. Species that once gathered in specific areas during certain tidal conditions develop new behavioral patterns. Fishermen find they must learn new timing and locations for successful catches, developing expertise in reading the subtler signs that fish populations follow in a world no longer dominated by lunar rhythms. Coastal erosion patterns shift dramatically as the reduced tidal action changes the forces that shape shorelines. Beaches that once experienced dramatic erosion during storm-driven high tides find themselves more stable, able to build up sand reserves that persist for longer periods. Sea cliffs that were undercut by twice-daily tidal action begin to erode more slowly, allowing coastal vegetation to establish more permanent footholds in previously unstable areas. The rhythm of coastal life itself adapts to the new patterns. Beachcombers and shell collectors find that the treasures washed up by the sea no longer follow the predictable schedule of tidal action. Instead, storms and seasonal changes become more important in determining when interesting objects appear on the beach. Coastal photographers discover new beauty in the more stable shoreline compositions, finding that the gentler water movements create different patterns in sand and foam. Aquaculture operations around the world must redesign their systems to work with the new tidal patterns. Oyster farms that relied on tidal flushing to bring nutrients and remove waste now need alternative systems to maintain water quality. Fish farms in coastal areas find that the reduced water exchange with the open ocean creates more stable local conditions, sometimes requiring adjustments to feeding and harvesting schedules. The Great Barrier Islands that protect many coastlines from ocean storms begin to evolve differently under the new tidal regime. Without the dramatic, twice-daily movement of water through the channels and lagoons behind these islands, sediment transport patterns change significantly. Some channels begin to fill in and become shallower, while others maintain their depth but develop different flow patterns. The protected waters behind barrier islands become more lake-like, supporting different communities of marine life. Submarine canyons and deep ocean trenches near the coast experience changes in their water circulation patterns. The powerful currents that once swept through these underwater valleys following tidal cycles now move according to different rhythms. Deep-sea creatures that evolved to take advantage of tidal flows for feeding adapt to new patterns of food delivery and water movement. Coastal bird populations adapt to the transformed feeding opportunities. Shorebirds that once timed their feeding to the exposure of mudflats during low tide develop new foraging strategies. Some species find that the more stable water levels actually provide more consistent feeding opportunities, while others must expand their feeding behaviors to include different habitats and food sources. The great seasonal migrations of shorebirds begin to follow new timing as the birds adapt to changed food availability along their traditional flyways. The traditional knowledge of coastal peoples around the world evolves to incorporate understanding of the new tidal patterns. Fishing techniques that were passed down through generations and tied to lunar cycles must be adapted to work with solar tides alone. The timing of shellfish gathering, seaweed harvesting, and other coastal activities shifts to follow new patterns of exposure and accessibility. Research stations studying marine ecosystems find themselves observing unprecedented changes in coastal environments. Long-term data sets that track tidal influences on everything from water temperature to species abundance must be reinterpreted. Scientists discover new insights into which aspects of coastal ecology were truly dependent on dramatic tidal changes versus those that can adapt to gentler fluctuations. The aesthetic experience of spending time by the ocean changes subtly but significantly. The hypnotic rhythm of waves that once varied dramatically with tidal stage now follows more consistent patterns. The soundscape of the shore changes as the reduced tidal range affects how waves break and how water moves across rocky surfaces. Beachgoers find that their favorite spots maintain more consistent characteristics throughout the day, allowing for more predictable planning of seaside activities. Engineering projects along coastlines must be reconsidered and redesigned. Seawalls and breakwaters that were built to withstand extreme high tides now deal with different stress patterns. Some coastal protection structures find themselves more effective in the new regime, while others become less necessary as the reduced tidal range decreases the force of water movement against the shore. The pharmaceutical industry that harvests marine organisms for drug development discovers new opportunities as previously difficult-to-access tidal zones become more consistently available for study. Researchers find that the more stable conditions in tidal pools and shallow coastal areas allow for more thorough investigation of the chemical compounds produced by marine life. Coastal real estate markets gradually adjust to the new reality of more stable but overall lower water levels. Properties that were once subject to regular flooding during extreme high tides become more developable, while others that depended on deep water access during high tide for their value must adapt to shallower conditions. The long-term planning for coastal development begins to incorporate the new tidal reality, creating more sustainable relationships between human habitation and the ocean. Deep beneath the surface changes that mark our moonless world, something far more profound begins to unfold. A transformation so gradual and gentle that it would take generations to fully manifest, yet so fundamental that it touches every aspect of life on Earth. Without the moon's steady gravitational hand to guide Earth's rotation, our planet begins to develop a subtle wobble in its spin, like a top slowly losing its perfect balance, but still spinning gracefully through space. This celestial dance, playing out over thousands of years, represents one of the most beautiful examples of how cosmic forces shape the most intimate details of terrestrial life. The Earth's axis, that imaginary line around which our planet spins once each day, has been kept remarkably stable for millions of years by the moon's gravitational influence. Like a cosmic gyroscope, the moon's presence has prevented our world from tilting too far in any direction, maintaining the relatively stable seasonal patterns that have allowed complex life to flourish. Without this stabilizing influence, Earth's axial tilt begins a slow, gentle wandering that unfolds over millennia, creating new patterns of seasons that transform the planet in ways both subtle and profound. Initially, the changes are so small as to be almost imperceptible. Astronomers tracking the position of stars notice minute shifts in the celestial pole, the point in the sky around which all the stars appear to rotate. The North Star, Polaris, which has served as a reliable navigation beacon for countless generations, begins a slow drift away from true north, though this movement is so gradual that it would take centuries for navigators to notice without precise instruments. This stellar wandering reflects the gentle beginning of Earth's new relationship with the cosmos, no longer locked in the moon's gravitational embrace, but free to explore new orientations in space. The first noticeable effects of this axial wandering appear in the subtle shifts of seasonal timing that occur over decades and centuries. Regions that have experienced winter during specific months for thousands of years find that their cold seasons gradually shift by days, then weeks, then months, as Earth's changing tilt affects which parts of the planet receive direct sunlight at different times of year. These changes unfold so slowly that each generation adapts naturally to slightly different seasonal patterns, creating a gentle evolution of climate that allows ecosystems and human societies to adjust without the shock of sudden transformation. The polar regions experience the most dramatic long-term changes as Earth's wobbling axis causes the Arctic and Antarctic to receive different amounts of sunlight over the great cycles of axial wandering. During some phases of this cosmic dance, the Arctic experiences longer, warmer summers that allow the ice cap to retreat significantly, opening vast areas of ocean and revealing land that has been locked beneath ice for millennia. In other phases, the polar regions become colder and darker, supporting the growth of ice sheets that extend much farther toward the equator than in our current world. These ice age cycles, no longer moderated by the moon's stabilizing influence, become more extreme and more frequent than they have been throughout human history. However, even these dramatic changes unfold over such long time scales that they represent opportunities for adaptation rather than catastrophes. Species migrate slowly with the changing climate zones, following their preferred temperature and precipitation patterns as these shift across the landscape over thousands of years. Forests gradually advance and retreat, mountain glaciers grow and shrink, and desert boundaries ebb and flow in response to the changing patterns of solar heating. The tropical regions of Earth experience their own gradual transformations as the wandering axis affects the intensity and duration of their wet and dry seasons. The great monsoon systems that bring life-giving rain to billions of people slowly shift their timing and intensity over the centuries. Some regions that have been tropical rainforests for millions of years gradually become more seasonal, developing distinct wet and dry periods that support different types of vegetation. Other areas that have been more arid find themselves receiving increased rainfall as the shifting climate patterns bring moisture to regions that have been dry for millennia. The desert regions of the world undergo perhaps the most beautiful transformations as the changing axial tilt affects global precipitation patterns. The Sahara, that vast sea of sand that has dominated North Africa for thousands of years, experiences cycles of humidity that gradually transform portions of it into grassland and even forest. Archaeological evidence from our own moon-stabilized history shows that such changes have occurred before during natural climate cycles, creating green corridors across what is now empty desert. In the moonless world, these transformations become more frequent and more extensive, creating a slowly shifting mosaic of climate zones that drift across the continents like gentle waves. Plant and animal life demonstrate remarkable adaptability to these gradually shifting conditions. Migration patterns that have been stable for thousands of years slowly adjust to follow changing resource availability and climate zones. Birds that have followed the same flyways for countless generations gradually shift their routes as the seasonal timing of food abundance changes across their range. Many species discover that the more variable climate actually provides opportunities for expansion into regions that were previously too stable to colonize. The great mountain ranges of the world become corridors for species movement as changing climate patterns create new habitats at different elevations. Animals and plants that were once restricted to specific altitude zones find themselves able to expand their ranges as temperature and precipitation patterns shift. The tree line on mountains gradually moves up and down over the centuries, creating new forests in previously alpine areas while opening high meadows where dense woodland once grew. Human civilization adapts to these changes with the same ingenuity and flexibility that has characterized our species throughout history. Agricultural systems evolve to take advantage of changing growing seasons and precipitation patterns. Crops that were once limited to specific regions gradually expand their range as climate zones shift, while traditional farming areas adapt by developing new crops and techniques suited to their changing conditions. The knowledge of how to adapt to changing climates, once possessed by nomadic peoples who followed seasonal resources, becomes valuable again as even settled populations learn to adjust to gradually shifting environmental conditions. Architecture and urban planning evolve to accommodate the changing seasonal patterns. Cities that were designed for specific climate conditions gradually modify their infrastructure to handle different temperature ranges, precipitation patterns, and seasonal light cycles. The great seasonal celebrations that mark important transitions in the year slowly shift their timing to match the gradually changing realities of local climate, creating new traditions while maintaining the essential human need to mark the passage of time and seasons. The ocean currents that distribute heat around the planet respond to the changing wind patterns caused by the shifting seasonal cycles. The Gulf Stream, that great river of warm water that brings mild climate to northern Europe, varies in strength and position over the centuries as atmospheric circulation patterns change with Earth's wobbling axis. These oceanic changes unfold slowly enough that marine ecosystems can adapt, but they create new patterns of climate that transform coastlines and influence weather patterns far from the ocean itself. The great ice sheets of Greenland and Antarctica experience cycles of growth and retreat that are more extreme than anything seen in our moon-stabilized world. During some phases of Earth's axial wandering, these ice sheets expand dramatically, locking up enormous amounts of water and causing global sea levels to drop significantly. During other phases, they retreat to small remnants, releasing their water back to the oceans and creating shallow seas in many areas that are now dry land. These cycles, playing out over tens of thousands of years, create opportunities for life to explore new habitats and evolve new adaptations. The aurora displays that paint the polar skies with curtains of colored light become more variable and unpredictable as Earth's changing magnetic field orientation affects how solar particles interact with the atmosphere. Sometimes the aurora appears much farther from the poles than usual, treating temperate regions to spectacular light shows that become part of local folklore and seasonal celebrations. Other times, the lights retreat to narrow zones around the magnetic poles, creating more concentrated but more intense displays that become pilgrimage destinations for people seeking to witness these cosmic dances. Weather patterns around the world become more diverse and more interesting as the loss of lunar tidal effects on the atmosphere combines with the changing axial tilt to create new circulation patterns. Storm systems develop different characteristics, following new paths across the continents and oceans. Some regions experience more gentle, consistent weather as the elimination of tidal atmospheric effects reduces day-to-day variability. Others find their weather becoming more dramatically seasonal, as the changing axial tilt creates stronger contrasts between summer and winter conditions. The timing of biological events, flowering, breeding, migration, hibernation, gradually shifts to match the changing seasonal patterns. Plants that have bloomed in response to specific day length and temperature combinations for millions of years slowly adjust their timing as these conditions occur at different times of year. Animals that hibernate through winter gradually alter the duration and timing of their dormancy to match the changing length and severity of cold seasons. These biological adaptations create new synchronizations between species that lead to the evolution of new ecological relationships. The calendar systems used by human cultures around the world undergo gradual evolution to maintain their relevance to changing seasonal realities. Agricultural calendars that mark planting and harvest times slowly shift to accommodate the changing growing seasons. Religious and cultural celebrations tied to seasonal events gradually adjust their timing to maintain their connection to the natural phenomena they commemorate. New traditions emerge to mark the unique seasonal events that occur as Earth's climate explores new patterns unknown in our moon-stabilized past. Scientific research takes on new dimensions as researchers work to understand and predict the long-term climate cycles that characterize the moonless world. Paleoclimatology, the study of ancient climates, becomes especially important as scientists work to identify patterns in Earth's climate history that can help predict future changes. Archaeological and geological evidence of past climate variations provides crucial insights into how ecosystems and human societies have adapted to similar changes in the distant past. The diversity of life on Earth actually increases over the long term as the more variable climate creates more ecological niches and opportunities for speciation. Populations of plants and animals that become separated by shifting climate zones gradually evolve into new species adapted to their local conditions. The increased variability in environmental conditions favors species that are more adaptable and more capable of surviving in changing conditions, leading to the evolution of more resilient ecosystems. Agriculture becomes more diverse and more distributed as changing climate patterns create new opportunities for crop cultivation in previously unsuitable regions. Traditional farming techniques that work well under variable conditions become more valuable than intensive methods that depend on stable climate patterns. The development of more adaptable crop varieties and more flexible farming systems becomes a priority as communities prepare for the gradually changing conditions that characterize their moonless world. The energy systems that power human civilization adapt to take advantage of changing wind and precipitation patterns. Regions that develop stronger or more consistent winds become better suited for wind power generation. Areas that experience increased precipitation become better suited for hydroelectric power. Solar energy systems adapt to changing seasonal light patterns, with some regions becoming better suited for solar power as cloud patterns change with the shifting climate zones. As Earth continues its gentle dance through space without the moon's stabilizing presence, the very nature of seasons begins to transform in ways both subtle and profound. The familiar rhythm of spring, summer, autumn, and winter that has governed life on our planet for millions of years starts to shift and flow like a vast, slow river finding new channels through the landscape of time. These changes unfold over decades and centuries, allowing each generation to adapt naturally to slightly different seasonal patterns while participating in a grand transformation that touches every aspect of terrestrial life. The spring awakening that has traditionally marked the end of winter begins to occur at different times in different years as Earth's wobbling axis creates variation in when specific regions receive the warming rays of the sun. In some years, spring arrives weeks earlier than expected, catching cherry trees and daffodils in a gentle confusion that leads to extended blooming periods as different plants respond to the varied signals of warmth and light. In other years, winter lingers longer, creating late springs that compress the growing season but often result in more intense bursts of flowering and new growth when warmth finally arrives. These variations in seasonal timing create new opportunities for life to explore different strategies for survival and reproduction. Plants that have relied on precise timing for millions of years begin to develop more flexible approaches to their annual cycles. Some species evolve the ability to bloom multiple times during favorable periods, while others develop extended dormancy periods that allow them to wait through less favorable years. The result is a more diverse and adaptable flora that can thrive under the changing conditions of the moonless world. Summer seasons become more variable in their intensity and duration as the shifting axial tilt affects how directly different regions receive solar radiation. Some summers become longer and more gentle, with moderate temperatures that extend the growing season and allow for multiple harvests of fast-growing crops. Other summers become shorter but more intense, concentrating the year's warmth into brief periods that create desert-like conditions in regions that are normally temperate. These variations lead to the development of new agricultural techniques and crop varieties that can take advantage of both types of summer patterns. The autumn transformation, that spectacular display of changing colors that marks the transition from growth to dormancy, becomes more unpredictable and often more dramatic as trees and other plants adapt to variable seasonal cues. In some years, the changing colors appear gradually over extended periods, creating autumn displays that last for months rather than weeks. In other years, the change happens rapidly, creating intense bursts of color that transform entire landscapes seemingly overnight. These varied autumn patterns become part of local culture and folklore as communities learn to appreciate the unique beauty of each year's seasonal display. Winter patterns show perhaps the most dramatic variations as the changing axial tilt affects how different regions experience the cold season. Some winters become milder and shorter, allowing many plants and animals to remain active throughout the year and creating conditions more similar to those found in subtropical regions. Other winters become longer and more severe, with extended periods of snow and cold that create conditions similar to those found near the Arctic Circle. These variable winter patterns lead to the evolution of more adaptable wildlife and the development of flexible human societies that can cope with both mild and severe cold seasons. The transition periods between seasons become more fluid and less predictable as the traditional markers of seasonal change, day length, temperature patterns, precipitation cycles, occur at different times and in different combinations than they have throughout recorded history. Spring might arrive with warm temperatures, but without the traditional change in day length, leading to confusion among plants and animals that rely on multiple seasonal cues. Autumn might bring shorter days, but continued warmth, creating extended growing periods that allow some species to complete multiple reproductive cycles in a single year. Agricultural systems around the world adapt to these changing seasonal patterns with remarkable creativity and flexibility. Farmers develop more diverse crop rotation systems that can take advantage of variable growing seasons. Traditional farming calendars based on fixed seasonal timing give way to more flexible approaches that respond to actual weather conditions rather than calendar dates. The development of hardy, adaptable crop varieties becomes a priority as communities seek to maintain food security under increasingly variable seasonal conditions. Wildlife migration patterns undergo gradual transformation as the changing seasons affect the timing and availability of food sources along traditional migration routes. Birds that have followed the same flyways for thousands of years begin to adjust their timing and routes to match the new patterns of seasonal resource availability. Some species discover that they no longer need to migrate as far as climate zones shift, while others find new opportunities to expand their range into regions that were previously too stable to support their lifestyle. The hibernation and dormancy cycles of many species become more flexible as winter patterns become less predictable. Bears, ground squirrels, and other hibernating animals develop the ability to enter and exit dormancy multiple times during variable winter seasons. Some individuals learn to take advantage of warm periods during typically cold months, while others develop extended dormancy periods that allow them to survive through unusually long or severe winters. These behavioral adaptations create more resilient wildlife populations that can thrive under variable conditions. Plant flowering and fruiting cycles become more complex and varied as species adapt to unpredictable seasonal cues. Many plants develop the ability to flower multiple times during favorable periods, increasing their reproductive success under variable conditions. Fruit trees and other perennial plants evolve more flexible fruiting patterns that allow them to take advantage of unexpected warm periods while protecting themselves during unexpected cold snaps. These adaptations lead to more diverse and productive plant communities. The timing of natural events that have traditionally marked the progression of seasons, the first flower blooms, the arrival of migrating birds, the changing of leaf colors, becomes more variable and unpredictable. Communities develop new ways of observing and celebrating seasonal changes that focus on the actual occurrence of natural events rather than fixed calendar dates. Local festivals and celebrations evolve to accommodate the changing timing of seasonal phenomena, creating more flexible cultural traditions that can adapt to variable conditions. Weather patterns within seasons become more diverse as the changing axial tilt affects atmospheric circulation patterns. Spring weather might include unexpected snowstorms or unusually warm periods that create dramatic contrasts within the season. Summer might feature extended periods of mild, cloudy weather interspersed with brief but intense heat waves. These varied weather patterns create more dynamic and interesting seasonal experiences while requiring greater adaptability from both natural ecosystems and human communities. The length of daylight during different seasons begins to vary as Earth's changing orientation affects how different regions experience the annual cycle of light and darkness. Some regions experience longer twilight periods that extend the effective daylight hours, while others find their days becoming more sharply defined between light and dark. These changes in light patterns affect everything from plant growth cycles to human sleep patterns, creating new rhythms of daily life that adapt to the changing relationship between Earth and Sun. Ocean temperatures and currents respond to the changing seasonal patterns of solar heating, creating new marine climate zones that shift gradually across the planet's surface. Coastal regions experience different seasonal temperature patterns as ocean currents adapt to new atmospheric conditions. Some areas become more moderate in their temperature extremes as changed ocean patterns provide more stable thermal conditions, while others experience greater seasonal contrasts as warm and cold water masses interact in new ways. The snow and ice patterns that define winter in many regions become more variable and unpredictable as changing seasonal conditions affect precipitation and temperature patterns. Some winters feature extended periods of snow cover that last well into traditionally spring months, while others see little or no snow accumulation even in regions that normally experience significant winter snow. These variable winter patterns affect everything from water supply systems to winter recreation activities. Growing seasons for agriculture become more varied in length and timing, requiring farmers to develop more flexible planting and harvesting strategies. Some years feature extended growing seasons that allow for multiple crops or late plantings that extend harvest periods well into autumn. Other years feature compressed growing seasons that require rapid planting and harvesting of crops that can mature quickly. These variable growing patterns lead to the development of more diverse agricultural systems and more adaptable farming communities. The seasonal availability of natural resources, wild foods, fresh water, building materials, becomes more unpredictable as changing seasonal patterns affect when and where these resources can be found. Traditional knowledge about seasonal resource gathering must be continuously updated and adapted to match changing conditions. Communities develop more flexible and diverse resource management strategies that can take advantage of unexpected abundance while preparing for periods of scarcity. Seasonal energy demands for heating and cooling become more variable as changing climate patterns affect temperature extremes and seasonal duration. Some years require extended heating periods due to longer or more severe winters, while others feature minimal heating needs but increased cooling demands during extended warm periods. Energy systems adapt to become more flexible and responsive to variable seasonal demands. The seasonal rhythms of human social and cultural life gradually adapt to the changing natural patterns. Traditional seasonal celebrations and festivals evolve to maintain their connection to natural phenomena, even as the timing of these phenomena becomes more variable. New traditions emerge to mark the unique seasonal events that occur under the changing climate patterns of the moonless world. Seasonal tourism and recreation activities adapt to the changing patterns of weather and natural phenomena. Ski resorts develop more flexible operating schedules that can take advantage of variable snow conditions. Beach and summer recreation areas prepare for seasons that might be longer or shorter than traditional patterns. Wildlife viewing and nature tourism adapt to the changing timing of animal migrations and plant flowering cycles. The seasonal cycles of human health and well-being adjust to the changing patterns of light, temperature, and seasonal activity. Traditional approaches to seasonal health maintenance evolve to address the challenges and opportunities presented by more variable seasonal conditions. Communities develop new understanding of how to maintain physical and mental health under changing seasonal patterns. The beauty and wonder of seasonal change becomes more diverse and unpredictable as each year brings unique combinations of weather, light, and natural phenomena. Artists, photographers, and nature lovers discover new opportunities to experience and capture the varied expressions of seasonal beauty that occur under the changing conditions of the moonless world. The appreciation of natural seasonal cycles deepens as people learn to find beauty in unexpected seasonal combinations and variable natural rhythms. In the gentle transformation of our moonless world, one of the most intimate changes touches the very rhythm of daily life itself. Without the moon's gravitational embrace to slow Earth's rotation through tidal friction, our planet begins to spin slightly faster, shortening each day by a few precious minutes. This acceleration happens so gradually that no single generation notices the change in their daily experience. Yet over decades and centuries, the cumulative effect creates a world where the familiar 24-hour day becomes a memory, replaced by something subtly but profoundly different that reshapes the most fundamental rhythms of existence. The change begins almost imperceptibly, with days shortening by mere seconds each year. Atomic clocks and precise astronomical observations detect the acceleration first, recording the gradual decrease in the time it takes Earth to complete one full rotation. The length of a day, which has been slowly increasing throughout human history due to lunar tidal friction, reverses its trend and begins a gentle decrease that will continue for millions of years. This cosmic speedup represents Earth's release from the Moon's gravitational drag, allowing our planet to spin more freely through space. Timekeeping systems around the world gradually adapt to accommodate the changing length of days. The precise definition of a second, based on atomic transitions, remains constant, but the number of seconds in a day slowly decreases. Calendar systems that have served humanity for thousands of years require subtle adjustments to maintain their alignment with the actual rotation of Earth. These changes happen so gradually that they become part of the natural evolution of human timekeeping, requiring periodic updates rather than dramatic revisions. The circadian rhythms that govern biological life on Earth, those internal clocks that regulate sleep, feeding, reproduction, and countless other biological processes, begin a slow adaptation to the changing day length. Plants that open their flowers at specific times relative to dawn find that their timing gradually shifts as dawn occurs slightly earlier each day. Animals that are active at particular times of day slowly adjust their behavior patterns to match the changing relationship between their internal clocks and the external cycle of light and darkness. Human sleep patterns undergo a gradual transformation as the shorter days affect the natural cues that regulate our rest cycles. Many people find that they naturally wake up slightly earlier each day, following the advancing sunrise that now occurs a few minutes sooner than their internal clocks expect. Others discover that they feel more alert in the evening as sunset arrives earlier, giving them more time to be active after their natural energy peaks. These subtle changes in sleep timing create opportunities for people to discover new daily rhythms that might be more aligned with their individual biological preferences. The measurement of work and leisure time adapts to the changing day length in ways that reflect human flexibility and creativity. Some societies choose to maintain the traditional 8-hour workday, which gradually becomes a larger fraction of the total day as days grow shorter. Others adjust their work schedules to maintain the same proportion of work to leisure time, creating slightly shorter workdays that preserve the balance between productive activity and personal time. These adaptations demonstrate humanity's ability to adjust social structures to match changing natural conditions. Agricultural systems adapt to the changing daily cycles by adjusting planting, harvesting, and animal care schedules to match the new rhythms of light and darkness. Farmers discover that some crops respond positively to the slightly shorter daily cycles, completing their growth cycles more efficiently under the changed light patterns. Livestock gradually adapt their feeding and activity patterns to match the new day length, often with improved health and productivity as their biological rhythms align with the changed environmental cues. The synchronization of biological processes that depend on precise timing becomes more complex as different species adapt at different rates to the changing day length. Pollinating insects might adjust their daily activity patterns more quickly than the flowers they pollinate, creating temporary mismatches that gradually resolve as all species in an ecosystem adapt to the new daily rhythm. These transitional periods create opportunities for some species to gain advantages while others face temporary challenges, leading to the evolution of more flexible biological timing systems. Communication and transportation systems that depend on precise timing gradually incorporate the changing day length into their operational schedules. Satellite systems that rely on Earth's rotation for positioning slowly adjust their calculations to account for the faster spin. Navigation systems that use the position of stars and the timing of Earth's rotation update their algorithms to maintain accuracy under the changing conditions. These technological adaptations happen seamlessly as engineers and scientists develop more flexible systems that can accommodate gradual changes in planetary conditions. The energy cycles that power ecosystems begin to shift as the changing day length affects the balance between photosynthesis and respiration in plants. Slightly shorter days means slightly less total sunlight each day. But this is often offset by the more efficient use of available light as plants adapt their photosynthetic cycles to match the new daily rhythm. Some ecosystems become more productive under the changed light cycles, while others require adaptations in plant species composition to maintain their energy balance. Weather patterns that are influenced by daily heating and cooling cycles adapt to the changing day length, creating new microclimates and local weather phenomena. The daily cycle of temperature variation, which drives many local wind patterns and precipitation cycles, adjusts to the shorter days by concentrating the same amount of heating and cooling into a smaller time period. This can create more intense daily weather cycles in some regions, while leading to more stable conditions in others. Cultural activities that are tied to specific times of day gradually adapt to maintain their social and spiritual significance under the changing daily rhythms. Religious observances that occur at sunrise, sunset, or other times relative to the daily cycle slowly shift their timing to maintain their connection to natural phenomena. Social activities that depend on specific lighting conditions or traditional timing adapt to preserve their cultural meaning while accommodating the practical realities of shorter days. The entertainment and recreation industries adapt to the changing daily rhythms by developing new schedules and activities that take advantage of the altered patterns of light and darkness. Outdoor sporting events and recreational activities adjust their timing to make the best use of available daylight. Evening entertainment extends later into the night as the earlier sunset creates longer evening periods. These adaptations often lead to the discovery of new forms of recreation that are particularly well suited to the changed daily rhythms. Educational systems gradually modify their schedules to align with the changing daily patterns while maintaining effective learning environments. School days might start slightly earlier to take advantage of the earlier sunrise, or they might be shortened slightly to maintain the same proportion of the day dedicated to formal education. These schedule adjustments often lead to improved learning outcomes as educational timing becomes better aligned with students' natural biological rhythms. The natural phenomena that mark the passage of time throughout the day, the movement of shadows, the changing quality of light, the behavior of wildlife, all adapt to the shorter daily cycle. Sundials and other traditional timekeeping devices require gradual recalibration to maintain their accuracy. The traditional divisions of the day into morning, afternoon, and evening shift their boundaries as the total day becomes shorter, creating new patterns of daily experience. Sleep research reveals new insights into human circadian biology as researchers study how people adapt to the gradually changing day length. Some individuals show remarkable flexibility in adjusting their sleep cycles, while others find the change more challenging and require assistance in adapting their rest patterns. These studies lead to improved understanding of biological timekeeping and the development of better treatments for sleep disorders that might arise during the transition to shorter days. The synchronization of global activities becomes more complex as different regions of Earth experience the changing day length differently due to their latitude and seasonal variations. International business and communication must account for the gradually shifting time differences that result from the changing rotation rate. These coordination challenges drive the development of more flexible international timing systems that can accommodate gradual changes in planetary rotation. Biological research discovers new aspects of how living organisms measure time and coordinate their activities with environmental cycles. The study of circadian rhythms expands to include adaptation to changing cycle lengths, revealing the remarkable flexibility of biological timing systems. This research leads to improved understanding of how life can adapt to changing planetary conditions and provides insights into the evolution of biological time-keeping mechanisms. The measurement of geological and astronomical time becomes more complex as the changing day length affects the relationship between Earth's rotation and other cosmic cycles. Geological processes that are measured in daily increments must account for the changing definition of a day. Astronomical observations that depend on Earth's rotation for timing require increasingly sophisticated calculations to maintain their accuracy over long periods. Urban planning and architecture gradually adapt to the changing daily light cycles by designing buildings and public spaces that make optimal use of the available daylight periods. Building orientation and window placement evolve to take advantage of the changing sun angles and daylight duration. Public lighting systems adjust their timing and intensity to match the new patterns of darkness and dawn. The natural world demonstrates remarkable resilience and adaptability as ecosystems adjust to the changing daily rhythms. Predator-prey relationships adapt to new activity patterns. Migration timing shifts to match change day lengths, and reproductive cycles evolve to maintain synchronization under the new temporal conditions. These biological adaptations showcase the flexibility of life and its ability to thrive under gradually changing conditions. Economic systems that depend on daily cycles of activity gradually adjust their operations to maintain efficiency under the changing temporal conditions. Stock markets and other financial institutions modify their operating hours to align with the new daily rhythms while maintaining their coordination with global markets. Manufacturing and service industries adapt their schedules to optimize productivity under the changed timing conditions. The psychological experience of time begins to shift as people adapt to the shorter days, with many individuals reporting changes in their perception of daily time passage and their ability to accomplish tasks within the available daylight hours. These perceptual changes often lead to improved time management skills and more efficient daily routines as people learn to make better use of the available time in each shortened day. Scientific research into the effects of changing day length on human health and performance reveals both challenges and opportunities for adaptation. Some individuals experience improved sleep quality and daytime alertness as their biological rhythms align better with the shorter daily cycles. Others require support in adapting to the changed timing, leading to the development of new therapeutic approaches for maintaining circadian health under changing environmental conditions. Beneath the surface of the world's oceans, where vast rivers of water have flowed along the same paths for millions of years, a profound transformation begins to unfold as the loss of lunar tidal forces allows these ancient currents to explore new routes across the planet. The great circulation systems that distribute heat, nutrients, and life itself throughout the marine world start to shift their patterns, creating a gentle reorganization of oceanic flow that touches every aspect of life, both in the sea and on the land that borders it. The Gulf Stream, that mighty river of warm water that has carried tropical heat from the Caribbean to the North Atlantic for countless millennia, begins to find new expressions of its ancient journey. Without the twice-daily pulse of lunar tides to constrain and channel its flow, this current gradually spreads wider and flows more smoothly across the ocean basin. The result is a more diffuse but more stable flow of warm water that brings milder temperatures to a broader area of the North Atlantic, creating more moderate climate conditions across a wider swath of northern Europe and eastern North America. This spreading and stabilization of warm water currents creates new marine ecosystems along their altered paths. Fish species that were once limited to narrow bands along the traditional current routes now find expanded habitat as the warming influence extends across broader areas of the ocean. Coral reefs discover new regions where they can establish themselves as the consistently warm water creates suitable conditions for their growth. The marine food webs that depend on the nutrients carried by these currents spread into new areas, supporting expanded populations of everything from tiny plankton to great whales. The deep ocean circulation system, that vast three-dimensional flow that carries water from the poles to the equator and back again over the course of centuries, undergoes its own transformation as the absence of tidal mixing allows new patterns of density-driven flow to establish themselves. Cold, dense water sinking at the poles and warm, light water rising at the equator create more stable and predictable circulation patterns that distribute heat and oxygen more evenly throughout the ocean depths. This enhanced circulation supports more diverse deep-sea ecosystems, as improved oxygen distribution allows life to flourish in previously marginal environments. The upwelling zones, where deep, nutrient-rich water rises to the surface, become more stable and more productive as the elimination of tidal interference allows these currents to flow more consistently. Coastal areas that depend on upwelling for their rich marine ecosystems experience enhanced productivity as the steady flow of nutrients supports larger populations of phytoplankton, which in turn support expanded populations of fish, seabirds, and marine mammals. These enhanced upwelling zones become even more important centers of marine biodiversity and fishing activity. The great oceanic gyres, those vast circular currents that span entire ocean basins, gradually shift their boundaries and intensities as the changed circulation patterns affect their formation and maintenance. The Pacific Gyre, the Atlantic Gyre, and their counterparts in other oceans find new equilibrium positions that redistribute heat and nutrients in different patterns across their basins. These changes create new climate zones along continental margins and alter the distribution of marine life across vast areas of the ocean. Coastal upwelling and downwelling patterns that have shaped regional climates for millions of years begin to operate under new rules as the absence of tidal forces allows wind-driven currents to dominate these processes more completely. Some coastal regions experience enhanced upwelling that brings cooler temperatures and increased marine productivity, while others see reduced upwelling that leads to warmer coastal waters and different types of marine ecosystems. These changes unfold gradually, allowing marine life to adapt and migrate to follow their preferred environmental conditions. The mixing of surface and deep waters that has been partially driven by tidal forces for millions of years shifts to depend more completely on wind, temperature differences, and the rotation of the Earth. This change often leads to more efficient vertical mixing in some regions, as wind-driven turbulence can penetrate deeper into the water column without interference from tidal currents. The enhanced mixing brings more nutrients to the surface while improving oxygen distribution in deeper waters, creating more productive and diverse marine ecosystems. Island nations and coastal communities around the world begin to experience new climate patterns as the altered ocean currents affect the temperature and humidity of air masses that pass over their regions. Some islands that were once in the path of cool currents find themselves influenced by warmer water, leading to more tropical climates and the ability to support different types of agriculture and tourism. Others that were once warmed by tropical currents experience cooler conditions that might require adaptations in lifestyle and economic activities. The formation and movement of sea ice in polar regions responds to the new ocean circulation patterns, creating different seasonal patterns of ice formation and melting. Arctic sea ice might form in different areas or persist for different lengths of time as the changed currents affect how warm and cold water masses interact in polar regions. These changes in sea ice patterns affect everything from polar bear hunting grounds to shipping routes through Arctic waters. Marine migration patterns that have been stable for millions of years begin to shift as fish, whales, and other sea creatures follow the changed distribution of food sources and favorable water conditions. The great whale migrations that have connected polar feeding grounds with tropical breeding areas gradually adjust their routes to follow the new current patterns. Fish populations that spawn in specific oceanic regions migrate to new areas as favorable conditions shift with the altered circulation patterns. The distribution of marine nutrients across the ocean basins changes as the altered current patterns affect how dissolved minerals, organic matter, and other essential substances move through the water. Some regions become more nutrient-rich as changed currents bring more resources from productive areas, while others experience reduced nutrient availability that requires adaptations in their marine ecosystems. These nutrient redistribution patterns create new opportunities for marine agriculture and aquaculture in previously unproductive areas. Coral reef systems around the world experience new growth patterns as the changed ocean currents affect water temperature, nutrient availability, and the distribution of coral larvae that establish new reef communities. Some reef systems expand into new areas as favorable conditions spread with the altered currents, while others might face challenges as changed circulation patterns affect their traditional sources of nutrients and favorable water conditions. The overall result is often a redistribution of reef environments that creates new opportunities for marine biodiversity. The deep-sea ecosystems that depend on the transport of organic matter from surface waters experience changes in their food supply as altered circulation patterns affect how nutrients and organic particles distribute through the water column. Some deep-sea communities receive enhanced food supplies as improved circulation brings more resources from productive surface waters, while others must adapt to change patterns of resource availability. These changes often lead to the discovery of new deep-sea species that are adapted to the altered conditions. Fishing industries around the world adapt to the new distribution patterns of commercial fish species as populations follow the changed ocean currents to new feeding and breeding areas. Traditional fishing grounds might become less productive while new areas develop strong fish populations. Fishing communities demonstrate remarkable adaptability as they learn new techniques and explore new areas to maintain their livelihoods under the changed oceanic conditions. The chemical composition of seawater begins to change gradually as the altered circulation patterns affect how different water masses mix and exchange their dissolved substances. These chemical changes can affect the growth of marine organisms, the formation of shells and skeletons, and the overall health of marine ecosystems. Research into these chemical changes helps scientists understand how marine life adapts to gradually shifting ocean chemistry. Coastal erosion and sediment deposition patterns change as the altered ocean currents affect how waves and water movement interact with shorelines. Some coastlines experience reduced erosion as calmer current patterns create gentler wave action, while others might face increased sediment deposition as changed currents carry more material to their shores. These changes create new opportunities for coastal development and new challenges for shoreline management. The formation of ocean weather patterns, storms, currents, and temperature variations adapts to the new circulation regime as atmospheric and oceanic systems find new ways to interact without the regular tidal pulses that have influenced their behavior for millions of years. Some regions experience more stable weather patterns as the smoother ocean circulation creates less variable conditions, while others discover new types of weather phenomena that emerge from the altered oceanic influences. Marine protected areas and conservation efforts adapt to the changing distribution of marine species and ecosystems as altered currents create new patterns of biodiversity and habitat distribution. Conservation strategies evolve to protect the most important areas under the new circulation patterns while allowing for the migration and adaptation of marine species to their changing environment. These adaptive conservation approaches often lead to more effective protection of marine biodiversity. The interaction between ocean currents and underwater topography creates new patterns of water flow around seamounts, ridges, and other underwater features. These changed flow patterns can create new upwelling zones, alter sediment transport, and affect the distribution of marine life around underwater geological features. The study of these interactions provides new insights into how ocean circulation affects marine ecosystems. Research into ocean circulation becomes more important as scientists work to understand and predict how the changed current patterns will affect climate, marine ecosystems, and human activities that depend on the ocean. Advanced computer models and monitoring systems track the gradual changes in circulation patterns, helping researchers develop better predictions of future oceanic conditions and their effects on global climate and marine life. The economic systems that depend on ocean resources, shipping, fishing, offshore energy production, and marine tourism, gradually adapt to the new oceanic conditions. Shipping routes might become more efficient as smoother currents reduce travel times and fuel consumption. Offshore wind and wave energy systems adapt to the changed patterns of ocean movement. Marine tourism discovers new opportunities as altered currents create new diving sites, fishing areas, and scenic oceanic phenomena. The cultural and spiritual connections that coastal peoples have maintained with the ocean evolve to incorporate understanding of the new circulation patterns. Traditional knowledge about ocean conditions, weather prediction, and marine resource availability adapts to remain relevant under the changed oceanic conditions. New traditions emerge to celebrate and honor the transformed ocean while maintaining the essential human connection to the marine environment. International cooperation in ocean research and management becomes more important as the changed circulation patterns create new shared resources and challenges that cross national boundaries. Treaties and agreements about ocean use, conservation, and resource management evolve to address the new realities of altered circulation patterns and their effects on marine ecosystems and human activities that depend on the ocean. In the transformed world without our moon, life demonstrates its most remarkable characteristic, the extraordinary ability to adapt, evolve, and thrive under changing conditions. From the smallest bacteria to the largest mammals, from ancient forests to delicate coral reefs, living organisms begin a gentle dance of adaptation that unfolds over generations, creating new patterns of existence that are both familiar and wonderfully different from the moon-influenced world that preceded them. In the forests of the world, trees that have marked their seasonal cycles by the phases of the moon for millions of years gradually shift to new rhythms based on stellar cycles, solar patterns, and the subtle changes in day length that characterize the moonless world. Ancient oak trees that once dropped their acorns in response to lunar cues begin to time their reproduction according to the position of bright stars and the gradual seasonal changes in daylight. These new timing patterns often prove more efficient, as they allow the trees to synchronize their reproduction with optimal weather conditions rather than following the somewhat arbitrary lunar calendar. The nocturnal animals that have navigated by moonlight throughout their evolutionary history develop enhanced abilities to use starlight for navigation and hunting. Owls discover that their extraordinary hearing becomes even more crucial for successful hunting in the deeper darkness, leading to the evolution of even more sensitive auditory systems over time. Their hunting patterns become more varied and creative as they learn to take advantage of the subtle light from stars and planets to locate prey with remarkable precision. Flowering plants around the world undergo a renaissance of diversity as they explore new pollination strategies in the absence of lunar timing cues. Many species that once bloomed according to moon phases develop the ability to flower continuously throughout favorable periods, creating extended blooming seasons that support larger and more diverse populations of pollinators. Night-blooming flowers, no longer competing with moonlight for the attention of nocturnal pollinators, often become more spectacular and more fragrant, evolving elaborate strategies to attract bats, moths, and other nighttime visitors. Marine life experiences perhaps the most dramatic adaptations as the absence of strong tidal forces allows new forms of coastal and intertidal existence to evolve. Creatures that once had to survive the twice-daily trauma of dramatic water level changes now thrive in more stable environments that allow for greater specialization and diversity. Tide pools become permanent miniature ecosystems that support complex communities of organisms that would never have been able to survive under the old regime of dramatic tidal fluctuations. Coral reefs expand into new areas as the more stable water levels and gentler currents create favorable conditions for coral growth in regions that were previously too turbulent or variable to support these delicate organisms. The reefs that do establish themselves become more complex and more diverse than their predecessors, as the stable conditions allow for the evolution of more specialized relationships between different species. New forms of coral, adapted to the slightly different light conditions and water chemistry of the moonless world, begin to appear and flourish. Bird migration patterns undergo gradual transformation as species that once timed their journeys according to lunar cycles develop new navigation strategies based on stellar positioning and seasonal changes in day length. Many species discover that they can make their migrations more efficient by following the more stable weather patterns that characterize the moonless world. Some birds find that they no longer need to migrate as far as climate zones become more stable and predictable, while others explore new migration routes that take advantage of the changed wind patterns and food availability. The intricate relationships between predators and prey evolve new dynamics as both hunters and hunted adapt to the changed environmental conditions. Without the regular rhythm of lunar cycles to coordinate breeding and movement patterns, many species develop more continuous reproductive strategies that reduce the vulnerability of having all offspring born at the same time. This leads to more stable population dynamics and often results in healthier ecosystems with fewer dramatic population swings. Pollinating insects that once synchronized their activity with lunar cycles gradually adapt to follow the blooming patterns of their preferred flowers, which now respond more directly to weather conditions and seasonal changes. This closer synchronization between pollinators and plants often results in more efficient pollination and increased plant reproduction. Bee colonies develop more flexible foraging strategies that allow them to take advantage of the extended blooming seasons that many plants now exhibit. Plant communities and regions with seasonal climates begin to show increased diversity as species that were once limited by strict lunar timing requirements explore new ecological niches. Forest understories become more complex as smaller plants develop strategies for thriving during the extended growing seasons that result from more stable seasonal patterns. Grasslands become more diverse as different species find opportunities to coexist without the competitive pressures that once resulted from lunar synchronized reproductive timing. Aquatic ecosystems that were once dominated by tidal rhythms develop new patterns of productivity based on solar cycles, seasonal temperature changes, and nutrient availability. Freshwater lakes and rivers that were indirectly influenced by lunar tides through their connections to coastal systems become more stable and often more productive. Fish populations in these systems develop more consistent breeding and feeding patterns that often result in larger and healthier populations. The soil ecosystems that form the foundation of terrestrial life undergo subtle but important changes as the organisms that decompose organic matter and cycle nutrients adapt to new seasonal patterns. Earthworms, bacteria, fungi, and countless other soil organisms develop more efficient recycling processes as they adapt to the more stable and predictable environmental conditions. This often results in richer, more fertile soils that support more robust plant communities. Hibernating and dormant organisms that once timed their rest periods according to lunar cues develop new strategies based on temperature, daylight, and food availability. Bears, ground squirrels, and other hibernating mammals often find that they can reduce their dormancy periods as the more stable climate conditions provide more consistent food supplies throughout the year. This allows them to remain active for longer periods and often results in healthier populations with higher reproductive success. Desert life adapts to the slightly increased humidity and more frequent gentle precipitation that often characterizes desert regions in the moonless world. Plants that evolved to survive in extremely arid conditions often thrive when given slightly more moisture, leading to the expansion of desert vegetation and the creation of new habitats for desert animals. Some desert regions gradually transition toward grassland or scrubland as the improved moisture conditions support more diverse plant communities. Mountain ecosystems experience vertical shifts in their plant and animal communities as the more stable climate conditions affect temperature patterns at different elevations. Tree lines gradually move higher up mountainsides as reduced climate variability creates more favorable growing conditions at higher altitudes. Alpine plants and animals often expand their ranges as the harsh conditions that once limited them to small areas become less severe. Symbiotic relationships between different species often become stronger and more complex in the more stable environmental conditions of the moonless world. Lichens, those remarkable partnerships between fungi and algae, often become more diverse and more productive as stable conditions allow for the evolution of more specialized relationships. Mycorrhizal fungi that partner with plant roots develop more extensive networks that improve nutrient cycling and plant health across entire ecosystems. Reproductive strategies across the animal kingdom become more diverse as species explore new approaches to timing their breeding activities. Many species develop extended breeding seasons that reduce competition for resources and improve the survival rates of offspring. Others develop the ability to breed multiple times per year when conditions are favorable, leading to more rapid population growth and recovery from environmental challenges. Seed dispersal mechanisms evolve new efficiencies as plants adapt to the changed patterns of wind, water movement, and animal behavior that characterize the moonless world. Some plants develop seeds that can remain dormant for longer periods, allowing them to wait for optimal germination conditions. Others develop more efficient dispersal strategies that take advantage of the changed movement patterns of animals and the altered wind and water currents. Social behaviors in animal communities often become more complex and cooperative as the more stable environmental conditions allow for the development of more sophisticated social structures. Pack hunting, cooperative breeding, and other forms of animal cooperation often become more common as stable food supplies and predictable environmental conditions reduce the competitive pressures that once limited these behaviors. The evolution of bioluminescence becomes more prominent in marine environments as the absence of moonlight makes light production more valuable for communication, mating displays, and predator deterrence. Deep-sea creatures develop more elaborate light displays, while surface-dwelling organisms create spectacular nighttime shows that become important parts of marine ecosystems. These bioluminescent displays often become more visible to human observers, creating new opportunities for marine tourism and research. Camouflage and defensive strategies evolve in response to the changed light conditions of the moonless world. Animals that once relied on moon shadows and lunar lighting for concealment develop new approaches that work with starlight and the deeper darkness. Some species become more cryptically colored to blend with their environments under the new lighting conditions, while others develop enhanced sensory abilities that allow them to detect threats and opportunities in the reduced visibility. Seasonal migration patterns in terrestrial animals often become more flexible as the stable climate conditions reduce the environmental pressures that once forced strict timing of movement between seasonal habitats. Some animals discover that they can remain in previously marginal habitats for longer periods, while others explore new seasonal ranges that were not viable under the more variable conditions of the moon-influenced world. The development of enhanced sensory abilities becomes common across many species as they adapt to the reduced visual environment of deeper nighttime darkness. Mammals develop more sensitive hearing and more acute senses of smell. Birds enhance their abilities to navigate by sound and magnetic fields. Fish and marine mammals become more sensitive to pressure changes, chemical gradients, and electrical fields that help them navigate and hunt in their environment. Plant chemical defenses and communication systems become more sophisticated as species develop new strategies for protecting themselves and communicating with other plants in the absence of lunar timing cues. Trees develop more complex chemical signaling systems that allow them to warn neighbors about insect attacks or environmental stresses. Many plants increase their production of protective compounds that help them survive in the changing environmental conditions. The timing of natural phenomena that depend on biological clocks gradually shifts to align with the new environmental rhythms of the moonless world. Flower blooming, fruit ripening, leaf color changes, and animal breeding all develop new synchronizations that often prove more efficient and more attuned to local environmental conditions than the previous lunar-influenced timing systems. Genetic diversity within species often increases as the more stable environmental conditions allow for the survival of individuals with a wider range of traits. This increased genetic diversity provides better insurance against future environmental changes and often leads to more resilient populations that can adapt more readily to new challenges. The result is often stronger, healthier species that are better equipped to thrive in their transformed world. Across the vast face of our moonless Earth, The very bones of the landscape begin to reshape themselves in response to the fundamental changes in gravitational forces, water movement, and climate patterns. This transformation unfolds with the patience of geological time, creating new mountains, valleys, coastlines, and landforms that tell the story of a planet learning to exist without its ancient companion. The changes happen so gradually that they become part of the natural evolution of Earth's surface, creating opportunities for new forms of beauty and new ecological niches that enhance rather than diminish the planet's diversity. The great river systems of the world begin to carve new channels through the landscape as the absence of tidal influences allows them to follow more direct paths to the sea. Rivers that once meandered extensively due to the complex interactions between their flow and tidal forces gradually straighten their courses, creating more efficient drainage patterns that often result in reduced flooding and more stable water supplies for human communities. The abandoned meanders become oxbow lakes and wetlands that provide valuable habitat for wildlife and natural water storage that helps moderate seasonal flow variations. Mountain ranges around the world experience subtle but significant changes in their erosion patterns as the altered precipitation and temperature cycles affect how water and ice work to wear down these ancient monuments of stone. Some mountain areas receive more consistent moisture that accelerates the gentle processes of chemical weathering, gradually rounding and softening the harsh angular features that characterize young mountains. Others experience reduced erosion rates that allow them to maintain their dramatic profiles for longer periods, creating more stable habitat for alpine plants and animals. Coastal landscapes undergo perhaps the most visible transformation as the reduced tidal ranges fundamentally alter the forces that shape shorelines. Beaches that once experienced dramatic daily reworking by powerful tidal currents develop more stable profiles, often building up higher dunes and more extensive sand reserves. Rocky coastlines that were constantly scoured by tidal action begin to accumulate sediment and organic matter in previously bare areas, creating opportunities for vegetation to establish footholds in formerly barren zones. The formation of new islands becomes more common in shallow coastal areas as the reduced tidal scouring allows sediment to accumulate in areas where it was previously swept away by strong currents. These new land formations often become important habitat for seabirds and marine mammals, while providing stepping stones for the dispersal of coastal plant species. Some of these new islands develop unique ecosystems as they become isolated enough to support the evolution of endemic species. Desert landscapes experience gradual transformation as the slightly increased atmospheric moisture and more stable climate patterns affect the processes of sand dune formation and movement. Many desert areas become more stable as vegetation is able to establish itself in areas that were previously too harsh or too mobile to support plant growth. The stabilization of sand dunes often reveals underlying rock formations and ancient landscapes that have been buried for thousands of years, creating new opportunities for both scientific study and scenic beauty. Volcanic landscapes around the world often become more predictable and less violently explosive as the changes in tidal stress on the Earth's crust reduce some of the triggers that can cause sudden volcanic eruptions. Many volcanic regions settle into more consistent patterns of gentle activity that create new land formations without the devastating explosive events that characterize some types of volcanic activity. This more stable volcanism often creates unique landscapes of slowly growing lava domes and gentle cinder cones that become important geological features. Cave systems and underground formations develop differently in the moonless world as the changed patterns of water infiltration and groundwater flow affect how these hidden landscapes form and evolve. Many cave systems become more extensive as the stable water conditions allow for more consistent limestone dissolution and other chemical processes that create underground spaces. These expanded cave systems often become important habitat for specialized cave-dwelling species and valuable sources of groundwater for human communities. Glacial landscapes in polar and high-altitude regions undergo transformation as the changed climate patterns affect how ice accumulates, flows, and melts in these sensitive environments. Some glacial areas experience more stable conditions that allow ice formations to persist and grow larger than they have in recent geological time. Others find their ice receding to reveal landscapes that have been hidden for thousands of years, creating new areas for colonization by plants and animals adapted to recently deglaciated terrain. Wetland landscapes expand significantly in many regions as the more stable water levels and reduced tidal action create conditions favorable for the development of extensive marsh and swamp systems. These new wetlands often form in areas that experience too much variation in water levels to support permanent wetland vegetation under the old tidal regime. The expanded wetlands provide crucial habitat for waterfowl and other wetland species, while serving important functions in flood control and water quality improvement. River delta systems around the world develop new configurations as the reduced tidal flushing allows sediment to accumulate in different patterns than those that characterize the moon-influenced world. Many deltas extend further into the ocean as the reduced tidal scour allows riverborne sediments to build up more consistently. These expanding deltas often create new land that becomes valuable for agriculture and wildlife habitat, while helping to buffer coastal communities against storm surges and sea level changes. The formation of natural terraces and stepped landscapes becomes more common as the stable water conditions allow for the consistent deposition of sediments over long periods. Rivers create series of terraces that mark their gradual downcutting through the landscape, while coastal areas develop raised beaches and marine terraces that record the changing relationship between land and sea. These terrace landscapes often become important agricultural areas and provide valuable records of environmental change. Limestone landscapes and karst formations develop more complex and extensive systems of surface and underground features as the stable water conditions allow for more consistent chemical weathering processes. Sinkholes, underground rivers, and surface limestone pavements become more common and more extensive, creating unique landscapes that support specialized plant and animal communities. These limestone landscapes often become important sources of groundwater and valuable areas for scientific study. Sand dune systems along coastlines and in desert regions often become more stable and more vegetated as the reduced wind variability and slightly increased moisture allow plants to establish themselves more successfully on previously mobile dunes. The stabilization of dune systems often creates more diverse landscapes with a mosaic of stabilized dunes, mobile sand areas, and interdune valleys that support different types of plant and animal communities. Salt flat and playa lake systems in arid regions often become more extensive and more permanent as the changed precipitation patterns and reduced evaporation rates create more stable water and salt accumulation processes. These unique landscapes often become important habitat for specialized halophytic plants and animals, while creating spectacular scenic areas that attract scientific study and tourism. Badland formations and other erosional landscapes often develop more intricate and more stable configurations as the changed precipitation patterns affect how water erosion carves these dramatic landforms. Many badland areas become more accessible to vegetation as the erosion processes become less violent and more predictable, creating unique landscapes that combine dramatic geological features with surprising biological diversity. The formation of natural bridges, arches, and other erosional features often becomes more common as the stable climate conditions allow for more consistent erosion processes that can create these spectacular landforms without destroying them through rapid or chaotic erosion. These natural monuments often become important landmarks and tourist destinations while providing unique habitat for specialized plant and animal species. Coastal cliff systems undergo gradual transformation as the reduced tidal battering allows vegetation to establish itself more successfully on cliff faces and in crevices. Many coastal cliffs become more stable and develop more complex ecosystems as plants and animals take advantage of the reduced erosion and more predictable environmental conditions. The stabilization of coastal cliffs often reveals geological features that were previously hidden by constant erosion. Valley systems around the world often become broader and more gently graded as the changed erosion patterns favor wider, more stable valley floors over the narrow, rapidly downcutting valleys that can result from variable climate conditions. These broader valleys often become important agricultural areas and provide more extensive floodplain habitat for riparian plants and animals. Highland plateau regions often become more dissected and more topographically diverse as the stable climate conditions allow for more consistent erosion patterns that carve more intricate drainage systems into these elevated areas. The increased topographic diversity often creates more ecological niches and supports greater biological diversity while creating more scenic and interesting landscapes. The development of natural amphitheaters and other erosional basins becomes more common as consistent weathering patterns create these spectacular landforms without the rapid destruction that can result from highly variable climate conditions. These natural amphitheaters often become important gathering places for both human communities and wildlife, while creating unique acoustic environments that enhance their cultural and ecological value. Soil formation processes become more efficient and more consistent as the stable climate conditions allow for more predictable weathering, organic matter accumulation, and biological soil development processes. Many areas develop deeper, richer soils that support more productive plant communities and more sustainable agricultural systems. The improved soil development often creates positive feedback loops that enhance ecosystem productivity and stability. The formation of natural levees and other flood control features becomes more common along river systems as the consistent flow patterns allow for more predictable sediment deposition during flood events. These natural flood control features often provide effective protection for human communities while creating elevated areas that support unique plant and animal communities adapted to periodic flooding. Scenic landscape features, such as natural gardens, rock formations, and geological showcases often become more accessible and more diverse as the stable environmental conditions allow for the preservation and development of these special areas. Many regions develop unique combinations of geological and biological features that create landscapes of exceptional beauty and scientific interest. The preservation of ancient landscape features becomes more common as the reduced environmental variability allows for the survival of geological formations and surface features that might have been destroyed by more chaotic climate conditions. These preserved ancient landscapes often provide valuable insights into Earth's geological history, while creating unique habitats for relict plant and animal species. In the transformed world without the moon, human civilization demonstrates its most remarkable characteristic: the ability to adapt, innovate, and thrive under changing conditions while maintaining the essential elements that make us human. Communities around the world begin to reimagine their relationship with time, nature, and each other as they adjust to the new rhythms of their moonless world. This adaptation happens gradually and thoughtfully, allowing each generation to build upon the innovations of their predecessors while discovering new ways to live in harmony with their transformed environment. Timekeeping and calendar systems evolve to reflect the new realities of the moonless world, moving away from lunar months toward systems based on stellar cycles, seasonal changes, and the subtly altered rhythm of day and night. Communities develop new ways to mark the passage of time that feel both familiar and refreshingly different. Some societies adopt calendars based on the position of bright star clusters, creating months that shift slowly through the year like a gentle cosmic dance. Others develop systems that mark time according to the flowering cycles of local plants or the migration patterns of animals, creating calendars that feel more connected to the immediate natural environment. Agricultural practices undergo a renaissance as farmers discover new freedoms in the absence of lunar planting traditions, allowing them to time their activities more precisely according to weather patterns, soil conditions, and the actual needs of their crops. Many farming communities find that this liberation from lunar timing constraints leads to more productive and more sustainable agricultural systems. Crop rotations become more flexible and more responsive to local conditions. Planting and harvesting schedules adapt to take advantage of the more stable seasonal patterns while allowing for the kind of fine-tuning that lunar cycles sometimes prevented. The art of navigation, both on land and sea, evolves to take advantage of the spectacular star displays now visible every clear night. A new generation of navigators learns to read the sky with a precision that rivals modern GPS systems, finding their way across vast distances using the patterns of stars, planets, and the slowly wheeling Milky Way. This revival of celestial navigation becomes both practical and deeply spiritual, connecting travelers to the cosmos in ways that technological navigation systems cannot provide. Sea captains and mountain guides develop an almost mystical ability to find their way using only the lights of the night sky. Architecture and urban planning adapt to take advantage of the new lighting conditions and changed environmental patterns of the moonless world. Buildings begin to incorporate more windows and outdoor spaces designed to take advantage of starlight and the softer ambient lighting that characterizes the deeper night. Cities develop new approaches to public lighting that complement rather than compete with the natural darkness, creating urban environments that feel more connected to the natural world. Parks and public spaces are designed to provide optimal stargazing opportunities while serving their traditional recreational and social functions. Cultural celebrations and festivals evolve to honor the new rhythms of the moonless world while maintaining their essential role in bringing communities together and marking important transitions. Harvest festivals shift their timing to align with actual agricultural cycles rather than lunar phases, often resulting in more joyful and more meaningful celebrations that truly reflect local growing conditions. Star festivals emerge in many cultures, celebrating the beauty of the night sky and the community's connection to the cosmos. These astronomical celebrations often combine scientific education with artistic expression and spiritual reflection. Traditional knowledge systems that were once based on lunar observations gradually adapt to incorporate stellar astronomy, seasonal plant cycles, and other natural phenomena that provide reliable indicators for everything from weather prediction to optimal timing for various activities. Elder community members work with younger generations to develop new forms of traditional knowledge that maintain the wisdom of the past while adapting to present realities. This knowledge evolution often leads to more accurate and more locally relevant understanding of natural patterns. Educational systems around the world discover new opportunities to connect students with the natural world through astronomy, ecology, and environmental science. The spectacular night sky visible in the moonless world becomes a natural classroom that inspires students to learn about physics, chemistry, biology, and mathematics through direct observation of celestial phenomena. Many schools develop outdoor education programs that take advantage of the enhanced visibility of stars, planets, and other astronomical objects. Economic systems adapt to the new patterns of productivity and resource availability that characterize the moonless world. Industries that once depended on tidal cycles for their operations develop new approaches that often prove more efficient and more sustainable. Fishing industries discover new patterns of fish behavior and develop innovative techniques that work with rather than against the natural cycles of marine life. Tourism industries develop new attractions based on stargazing, ecological observation, and the unique natural phenomena that characterize the moonless world. Transportation systems evolve to take advantage of the more stable weather patterns and the enhanced navigation opportunities provided by the brilliant night sky. Maritime shipping discovers new efficiencies as the calmer ocean conditions and improved celestial navigation create safer and more predictable travel. Overland transportation benefits from the more stable weather patterns while developing new techniques for night travel using stellar navigation. Aviation adapts to the changed atmospheric conditions while taking advantage of improved visibility for nighttime flying. Energy systems begin to incorporate new technologies that take advantage of the changed environmental conditions of the moonless world. Wind power systems adapt to the altered atmospheric circulation patterns, often finding more consistent and more predictable wind resources. Solar power systems adjust to the slightly different light patterns while developing new applications for the enhanced ambient light available during the darker nights. Hydroelectric systems benefit from the more stable water flow patterns that characterize many river systems in the moonless world. Healthcare and medicine develop new understanding of how human biology adapts to the changed environmental conditions, leading to improved treatments and prevention strategies for health issues that might arise during the transition to moonless living. Research into circadian rhythms and sleep patterns provides new insights into human biology while developing therapies that help people adapt to the new daily cycles. Traditional medicine systems incorporate new knowledge about plant cycles and environmental patterns that affect the availability and potency of medicinal plants. Communication systems evolve to support the more widely distributed communities that often develop in the moonless world as people discover new areas suitable for habitation. Advanced communication technologies allow remote communities to maintain strong social and economic connections while preserving their local adaptations to moonless living. Traditional communication methods, such as signal fires and sound-based systems, often become more effective in the changed atmospheric conditions. Scientific research experiences a golden age as the enhanced astronomical visibility and the unique environmental conditions of the moonless world provide new opportunities for discovery and understanding. Astronomy advances rapidly as observers gain access to celestial phenomena that were previously obscured by moonlight. Ecology and environmental science benefit from the opportunity to study ecosystems that are adapting to fundamentally different conditions. Climate science develops new understanding of how planetary systems respond to major changes in gravitational influences. Art and literature flourish as creative individuals find inspiration in the transformed world around them. The spectacular night sky provides new subjects for visual artists, while the changed rhythms of daily and seasonal life inspire writers to explore new themes and new forms of expression. Music evolves to incorporate the sounds of the moonless world, the enhanced natural sounds that are more audible in the deeper quiet of night, the new patterns of wind and water movement, and the subtle acoustic changes that characterize the transformed environment. Philosophy and spirituality develop new perspectives on humanity's place in the cosmos as people adjust to living on a planet that has been freed from its ancient gravitational partnership. Many individuals find that the loss of the moon creates a greater sense of connection to the broader universe, as the spectacular star displays visible every night serve as constant reminders of Earth's place in the cosmic community. New spiritual practices emerge that honor both the memory of the moon and the beauty of the star-filled sky that has replaced it. Recreation and leisure activities adapt to take advantage of the new opportunities provided by the moonless environment. Stargazing becomes a popular community activity that brings people together while providing education and inspiration. Night hiking and camping become more rewarding as the enhanced darkness creates new opportunities to experience wildlife and natural phenomena. Water sports benefit from the calmer and more predictable water conditions, while winter sports often become more accessible as weather patterns become more stable and more predictable. Social structures often become more collaborative and more community-oriented as people work together to adapt to the changing conditions. The shared experience of adapting to moonless living creates strong bonds between community members while encouraging the development of mutual support systems that enhance everyone's quality of life. Traditional governance systems evolve to incorporate new decision-making processes that are better suited to the collaborative problem-solving required for successful adaptation. International relations and global cooperation develop new dimensions as nations work together to understand and adapt to the worldwide changes that accompany the loss of the moon. Scientific cooperation increases as researchers share knowledge about adaptation strategies and new discoveries related to moonless living. Cultural exchange flourishes as communities learn from each other's innovations and adaptations. Economic cooperation expands as nations develop new trade relationships based on the changed patterns of resource availability and production. Technology development accelerates in areas related to astronomy, navigation, agriculture, and environmental monitoring as societies invest in tools and systems that support successful adaptation to moonless living. Advanced materials science develops new applications for the changed environmental conditions. Computer systems and artificial intelligence evolve to help communities manage the complex adaptations required for thriving in a moonless world. Biotechnology advances as researchers work to understand and support the biological adaptations that accompany the transition to moonless living. Urban planning evolves to create cities that are more responsive to the natural environment and more supportive of human community in a moonless world. Green spaces become more important as people seek connection with the natural world during their adaptation to change conditions. Public spaces are designed to facilitate both daytime activities and the stargazing and evening social activities that become more important in the moonless world. Transportation systems within cities adapt to support the new patterns of daily activity that characterize moonless living. The preservation of cultural heritage becomes more important as communities work to maintain their essential identity while adapting to dramatically changed environmental conditions. Traditional stories, songs, and practices evolve to incorporate the new realities of moonless living while preserving their core cultural values. Museums and cultural institutions develop new approaches to education that help people understand both their cultural heritage and their place in the transformed world. Education systems at all levels adapt their curricula to prepare students for successful living in the moonless world while maintaining the fundamental knowledge and skills that define human learning. Environmental education becomes more important as students need to understand the changed ecological systems they will inhabit. Astronomy and physics education expand to help students navigate and understand their relationship with the cosmic environment. Social studies curricula evolve to help students understand how human societies adapt to environmental change while maintaining their essential humanity. As we come to the end of our gentle journey through the moonless world, we find ourselves in a place of profound tranquility, gazing up at a sky that has become more beautiful, not less, in the absence of our ancient companion. The transformation that began with the simple disappearance of that familiar silver orb has blossomed into something far more magnificent. A world that has discovered new forms of grace, new rhythms of existence, and new ways of being beautiful that speak to the endless creativity of life itself. The night sky above you now holds a beauty that surpasses anything our moon-blessed ancestors could have imagined. Where once a bright disk dominated the heavens, washing out the fainter lights beyond, now stretches an infinite tapestry of stars that seems to pulse with gentle life. The Milky Way flows overhead like a celestial river, its countless suns creating a soft luminescence that bathes the world in starlight. Planets wander their ancient paths more visibly now, appearing as bright jewels against the velvet darkness. The aurora dances much farther from the poles, painting the sky with curtains of green and gold and purple light that seem to celebrate the planet's newfound freedom. This deeper darkness has revealed not emptiness, but fullness, a universe teeming with light and beauty that was always there, waiting patiently to be discovered. Children growing up in this moonless world will never know what they've missed, but they will know intimately the particular joy of finding the brightest star to wish upon, of learning to navigate by the patterns of constellations that wheel overhead with perfect reliability, of experiencing the profound peace that comes from lying beneath in sky so full of distant suns that it seems impossible to feel alone in the universe. The ocean that stretches to the horizon moves with a gentler rhythm now, its waves rolling in patterns that speak of peace rather than drama. Without the moon's gravitational pull to create the massive tides that once swept across the shores twice each day, the sea has found a kinder relationship with the land. Tide pools have become stable underwater gardens where delicate creatures can build more complex communities. Beaches have grown wider and more welcoming. Their sand no longer scoured away by dramatic tidal changes, but allowed to accumulate into soft, inviting shores where children can play and artists can create their temporary sculptures without fear of the next high tide washing their work away. The forests that cover the hills and valleys have grown richer and more diverse in their freedom from lunar timing. Trees bloom when weather conditions are truly optimal rather than following the somewhat arbitrary schedule of moon phases. The understory has become more lush and complex as plants explore new strategies for growth and reproduction. Wildlife moves through these woods with less urgency, following rhythms that are more closely tied to their actual needs for food, shelter, and companionship rather than the ancient pull of lunar cycles. Rivers run with steadier voices, their songs less interrupted by the ebb and flow of tidal influences. Fish populations have grown more stable and more abundant as their spawning and migration patterns adapt to more predictable environmental conditions. The water itself seems clearer and more peaceful, reflecting the star-filled sky with perfect clarity during the long, gentle nights. Human communities in this transformed world have discovered new forms of beauty in their daily lives. Towns and cities are lit more softly now, their artificial illumination designed to complement rather than compete with the natural starlight. Evening gatherings under the open sky have become common as people rediscover the joy of spending time outdoors when darkness brings beauty rather than fearsome isolation. Children learn astronomy as naturally as they once learned to read, finding their favorite stars and constellations with the easy familiarity that their ancestors reserved for earthbound landmarks. The seasons flow with gentler transitions now, each one arriving more gracefully and lingering more peacefully than in the old world of dramatic lunar influences. Spring emerges gradually, with flowers blooming in extended sequences that create longer periods of natural beauty. Summer settles in with comfortable stability, providing reliable, growing conditions that support more abundant harvests. Autumn arrives with spectacular displays of color that often last for months rather than weeks. Winter brings peaceful rest rather than harsh survival challenges, as the more stable climate patterns create conditions that are challenging enough to provide the renewal that comes with seasonal change while remaining gentle enough to allow all life to thrive. This moonless world has revealed that beauty does not depend on any single element, no matter how cherished or familiar it might have been. The absence of the moon has not created emptiness, but rather has allowed other forms of beauty to emerge and flourish. The darkness that remains is not barren, but rich with possibility. The changed rhythms are not chaotic, but harmonious in new ways. The transformed landscapes are not diminished, but enhanced by their freedom to explore new forms of grace. The people who live in this world have learned that adaptation and beauty are not opposite forces, but partners in the dance of existence. Every challenge that arose from the moon's absence became an opportunity to discover new solutions, new ways of living, new sources of wonder and joy. The communities that emerged from this great transformation are often more collaborative, more creative, and more connected to their natural environment than they were before. The technologies that developed to meet the needs of moonless living often prove more elegant and more sustainable than their predecessors. As you rest now in this peaceful world, feeling the gentle breeze that carries the sense of flowers blooming according to their own inner wisdom rather than lunar compulsion, listening to the soft sounds of wildlife that has learned to thrive in the deeper darkness, gazing up at stars that seem to twinkle with extra brightness in their joy at finally being seen clearly. You might find yourself grateful for this transformation that initially seemed like such a loss. The moon was beautiful, certainly, and its absence marks the end of one chapter in Earth's long story. But the world that has emerged in its wake is beautiful too, in ways that are both familiar and wonderfully new. This is still the same planet that cradled the first stirrings of life billions of years ago, still the same world that has nurtured consciousness and love and art and music throughout the long journey of evolution. It is still home, still beautiful, still full of wonders waiting to be discovered. In this moonless world, every clear night is an invitation to rediscover the universe. Every tide pool has become a stable window into the intricate beauty of marine life. Every forest has become a more complex symphony of interconnected life. Every season has become a gentler teacher about the rhythms of renewal and rest. Every human community has become an experiment in creative adaptation and mutual support. The beauty of this transformed world lies not in any single spectacular feature, but in the harmony of all its elements working together in new ways. The starlight and the stable seas, the gentler seasons and the more abundant forests, the collaborative communities and the innovative technologies, all of these create a world that is profoundly beautiful in its wholeness, its balance, its gentle creativity. So rest now in this peaceful place, surrounded by a beauty that needed no moon to make it complete. Let the soft starlight and the gentle sounds of the transformed world ease you into sleep. Dream of the endless creativity of life, of the way consciousness adapts and flourishes under any conditions, of the profound beauty that emerges when change is met with wisdom and grace. Sleep well in this moonless world, knowing that beauty takes infinite forms, and that home is wherever love and wisdom and wonder can take root and grow. The stars are watching over you now, as they always have, as they always will, in this different but equally beautiful world that we have inherited and learned to love.